In this video, we're going to look at creating a histogram with a graphing calculator, more specifically with a TI-83 and a TI-84. And we're going to look at two ways that you could be given data. The first way is going to be, what if you're just given the list of data points? And the second is, what if the data is already into some type of group frequency distribution? Let's go ahead and start with the first one. And we're going to use examples to look at this. So, histogram from a list of data. Here we have the list of the highest temperatures in degree from each 50 states, and we're going to use 7 classes to make a histogram out of this. So we got all the numbers here. What we need to do first is we're going to list all of the data into L1. So I'll have a bunch of screenshots of what the calculator screen would look like and the buttons that you would need to click in order to get to those screens. So we're going to type all that information into L1. Well, how do we get to L1? We need to get to this screen right here. We do that by clicking the stat button. And once you click the stat button, you need to highlight the part that you're going to enter all the data in. We're going to edit a list here, so make sure 1 is highlighted. You can either hit the number 1 or highlight 1 and hit enter. And then we go over here, and just a precautionary thing, if there's already data points listed into L1, we need to clear it out, highlight L1, and then hit the clear button. Then once everything is cleared, we'll go ahead and type in all of our data points. So we just go through our list. And then as you'll do this, you type it in, you see all of my numbers here, and it'll tell you after you hit number, hit enter, type in the next number, hit enter, and so on until you get all the data points put into L1. Next thing we're going to do is we have to set up what we call plot 1. Now we get to this by first hitting the Y equals button. What you have to be careful with here is sometimes there may be a function or some type of an equation already typed into Y1, and if that Y1 happens to be highlighted, it's going to graph that function. So we need to unhighlight that. So we left arrow over and then make sure that equal sign does not have a black box around it. The next thing that we'll do is we need to make sure plot 1 is highlighted. So you'll notice that plot 1 up here is highlighted in black, which means that we will be graphing the data onto this. Had it not been highlighted, then plot 1's data from L1 would not end up on our graph. Okay, so what we do, then we have to go into what we call stat plot. Now we have to do some buttons to get the stat plot. How do we do that? We have to hit the second button, and then the second function of the Y equals button is the stat plot. And you'll see that right above the Y equals button on the calculator. And just like we had to get rid of the highlighting over the equal sign, we need to do the same thing here for this. We need to click on highlight 1, because we're going to enter all our data into stat plot 1. We're going to click on it, and you're going to end up seeing this screen. We need to make sure that for stat plot 1 that on is highlighted. Next, we're doing a histogram. You'll notice these are all the different types of graphs that you can have in here. You can have box and whiskers and so on, but we're doing a histogram, so the one that looks kind of like a bar graph, that's the one that we're going to use, so make sure that is highlighted. Next, we need to, well, basically what it's asking is where do we enter all of our data? We entered all of our data into L1, so make sure that our X list is L1, so it uses all those data points. And the next important thing is, if we're just given a list of data, our frequencies, we're just going to put a 1 there for the frequency. And I guess if you'd like to, we could change the color of the graph, but we're going to go ahead and stick with blue. And there you go, you have everything entered into the stat plot. The third thing that we will do is we're going to set our window, because if we don't change the window to our graph, you're not going to see the picture of the entire histogram. Our graph is set up to where it's just in your standard coordinate plane. We'll usually give you from -10 to 10 on the x-axis, -10 to 10 on the y-axis. So we're going to change that. How do we do that? We get to this screen by hitting the window button. And then we're going to change some of these values here. We have an x-min, x-max, what's the scale? So we're saying how low do we want to go on the x-axis? How high do we want to go on the x-axis? What's the scale that you would like to go by on the x-axis? And the same thing for the y's. What we're going to do for the x-min is we're going to enter in our lower boundary. And think back to how do we find boundaries. The lower one we subtract another decimal point away that ends in a 5. And then for the x max, we're going to enter the upper boundary. So in the upper boundaries, we want to add a decimal point up by a half or a 0.5. And then our scale, we're going to use our class width to do the scale for the x-axis. So how do we find that class width again? Well, we need to find the range of our data, and we're going to divide it by the number of classes that we're looking for. And whatever that number is, we round it up to the next whole number. So if we think back, our highest number in our data was 134. The lowest number in our data was 100. We wanted 7 classes, which divides out to 4.5. Round that up to 5. Then our x scale would be 5. So we change all of those. We highlight those numbers. We use our arrows. And once they're highlighted, then we type in what we need, and then we hit enter, and it will jump down to the next number, and we continue to do all that. If we do that, so our smallest degree Fahrenheit was 100, so we just subtract a half away from that for our lower boundary, so we get 99.5. Our highest degree was 134. We're adding up a 0.5 to that, so we get 134.5. And then we already discussed the class width, so that scale, we're going to make it a 5. Now, what you'll also notice is that we changed the y min and the y max. The reason why I'm putting a -5 here is just so that my graph does not it doesn't just butt up at the very bottom of the screen. I'd like a little bit of space between the x-axis and then underneath for the y. So this number right here, you could put whatever you would like, as long as it's 0 or something slightly smaller than 0. And then for the x max, we want to make sure that this number is larger than the mode of the data set, or whatever the highest number of frequency is here. So we don't really know what the frequency is. We could change this number quite often. I'm going to go ahead and just for now put 40 in there. But those are the 5 main things that we need to have in our window. Once that window is set, the last thing we got to do is just go ahead and hit graph, and then we're going to interpret that data. So when we hit the graph button, our histogram will look something like this. Now, we don't know the frequencies of all these classes that we have here, but we can find that pretty simple. The way we do this, and again, there's a reminder that we can hit the graph button, but to find those frequencies, we hit the trace button. Once you hit that trace button, you'll see that there's a little spider that falls on top of that histogram. That tells you, from here, you'll see some numbers. First, we're going to look at these two. The minimum is going to be your lower class boundary for the data. The max is going to be the upper class boundary for that data. And then the n, right here, will be the frequency. So if I look at the class down here, notice that, remember, the lower class boundary is always smaller than what the class limit is. So we round that back up to 100, and that the upper class limit, or the upper class boundary, is always slightly larger than the upper class limit. So we round that back down to 104. So the class for this particular part of the histogram is 100 to 104. How many data points fell within 100 to 104? The frequency was 2. How do you find those frequencies and the class limits for all the other parts of the histogram? It's actually pretty simple. All you got to do is stay on that screen and hit the right arrow, and it will jump over to the next bar of the graph. Now you'll see the new upper and lower class boundaries, so then we can go ahead and find those class limits and the frequencies. So in this case, there's our numbers for the boundaries. That means our class limits are going to be 105 to 109, and then the 8 tells us how many of those data points are within that class, so the frequency is 8. Go on to the third one. We see here, there's our class boundaries. So our class limits are going to be 110 to 114, and that has a frequency of 18. And just keep hitting the right arrow, and you'll get all of the rest of the data points for the classes and their frequencies within that class. And that's how you'll do a histogram if you're just given a list of data. How about the other way? What if we're already given the group frequency distribution that goes with a list of data? And to do that, I'm going to go back to an old example that we've done. Remember the Electoral College votes of 2016? We had all this data, and we used it to come up with a group frequency distribution. Let's remind you of what that group frequency distribution is. Here we had our class limits, those limits, we came up with boundaries, and we had all the frequencies that go with this. What this is going to allow us to do is it's going to introduce us to a new concept that will make histogram much easier, and that is called a midpoint. Midpoint, very similar to your geometric term on midpoints in the coordinate plane. How do we find a midpoint? We do this by taking the lower class boundaries, or just one of the lower class boundaries, and we're going to add it to the upper class boundary, and we're going to divide it by 2. So for example, I can take 2.5, add it to 10.5, and then divide that by 2. That'll tell me what the midpoint of that particular class is. All right, so there would be some slight differences here when you're given that group frequency distribution as opposed to the list of data. So step 1, we're going to put the list of midpoints into our list of L1 and our frequencies in L2. So we're going to utilize 2 lists this time instead of 1 list. So we go to our stat table. Now what you'll notice here is if you look down at L1, I went ahead and just used the formula for the midpoint to type in all of those. Did my lower class boundary plus the upper class boundary, and then I divide it by 2, and when you hit enter, it does the math for you, and it gets 6.5 for its midpoint. If you do that for the rest of these, you'll get the 14.5, the 22.5, and so on. Then I arrow over to L2, go back to my table, and I type in all those frequencies. The class from 3 to 10 had 34. The class from 11 to 18 had 11, and again, there's all those frequencies there. Once we have everything entered into those lists, we're good to get out of that screen. Okay, second, we're going to set up our plot 1 again. This will again be slightly different than what we discussed in the previous example, and I'll show you when we get to that point. But a lot of the steps are the same. If you need to, this is not always necessary, but check the y equals. Okay, make sure that there's no equation in there, no function that is highlighted. If this is highlighted, we need to get rid of it. So just simply highlight it again, hit equals, and it'll get rid of it. Then go up to plot 1, make sure plot 1 is highlighted. And then we go to our stat plot screen. We get there by hitting second, y equals. Highlight the 1 and hit enter. And then go through all of our situations here. We want to make sure that on is selected, so these data points get listed. Make sure that histogram is highlighted. And here's where it gets slightly different. Our X list, all of our midpoints were listed as L1, but now instead of our frequencies being listed as the number 1, the frequencies were in list 2, so we need to make sure that is turned into an L2. We do that by hitting second, and I believe the number 2. The second function of the number 2 is L2. And like I said previously, if you'd like to change the color, you can. Otherwise, I'm just going to go ahead and keep it as blue. All right. So there we go. What's our third step? Well, just like our last example, we need to set the window that goes with this. Okay, there's your standard window, and we do get that by hitting the window button, but we're going to change a lot of these numbers once again. The first one, our lower class boundary of the very first class is going to go where the x min is at. Our upper class boundary of the last class will go where x max is at. Our class width will go where the x scale is. The y min, we just need to make sure that is a value that's slightly below 0 so our graph doesn't cut off at the very bottom of the screen. And then our x max, we want that value to be larger than the highest frequency. Now, it would be much easier to find the x max since our frequency distribution has all the frequencies listed in them. So if we do that, looking at our frequency distribution here, we see that our lower class boundary of the very first class is 2.5, so I'll go ahead and make my x min 2.5. The upper class boundary of the last class is 58.5, so that's why I'm going to make the x max. Now our class width, finding our range, our highest data point was 58, our lowest was 3, so 58 minus 3 divided by 7 gives us 7.9, and we round that number up, we get to 8, so our x scale will be an 8. And then our y min, I'm going to keep it at a -5 just so my graph to shift it up a little bit, makes it a lot more visible for me. And then since our largest frequency was 34. I just need a number larger than 34. I'm going to go ahead and pick 40. That number, you get to pick whatever you would like. But those are the, again, the 5 main things that we need to make sure our window is changed into. Now we can go ahead and graph. We're going to graph and interpret. So just like the last example, we're going to hit the graph button. There's our frequency distribution. And then we can go in and hit the trace button and find all of those frequencies and their lower and their upper class boundaries to go with it. And again, we can do that by hitting the trace. If you would like to find all the other frequencies, we just hit the right arrow and you'll have all of the frequencies for every class that is within that distribution. Okay, so well, there you go. You see this one's got 34, and we also know that by looking at our frequency distribution from the table previously. All right, so there you have it. That's how you create a